Good afternoon, everyone. Since there still seem to be a few people walking around looking for the right venue, let's just confirm. This is the Seagate presentation, also going under the name of EVault, and we're going to be talking about the role of storage in OpenStack and in the broader context of scale-out object storage. So hopefully that's what you're here to listen to. If not, then you might want to move to the other room. The other point is the presentation is described, and I'm going to read the title here, as OpenStack Storage Explained from the Source. I'd like to clarify that isn't the full title. The title should be The Role and Economics of Storage in OpenStack from the Source. So I'm not going to be doing a deep dive on either Swift or Cinder storage, although I'd be happy to have that conversation. The presentation that I'm actually going to be giving is really an economic one. It's not a commercial one. I'm not going to be explaining my company's products, but we're going to be looking at the economic drivers and the way in which storage is used and deployed within OpenStack storage environments. So again, want to set expectations accordingly. If you were expecting to hear about rings and proxy servers, that's not what I'm going to be talking about. Be happy to have that conversation downstairs. If you're interested to hear about getting to the right TCO to run competitive services, whether that's internally within an enterprise or as a service provider, then you're in the right place, because that's what I'm going to be talking about today. Okay, so I'm going to start now. I hope that we won't have too many more late arrivals. So the presentation then is, I do want to explain to you something that's changed. You may well know the name Seagate, and you probably think of 3.5 or 2.5 inch drives. Some big things have been changing in the disk world. If you follow the press recently, Seagate has been making acquisitions. I've come to Seagate as part of one of those recent acquisitions within the last year, within the last 6 months. So Seagate and our competitors in the drive industry were all moving up the supply chain, moving up the value stack. And so I want to talk to you a little bit about Seagate, one slide, and one slide about what the vision is for this new business, this Seagate systems business, which is really why we're here today, able to engage in a meaningful way, talking about larger scale OpenStack deployments. We'll talk about the role of storage in the cloud. We'll talk about block storage and object storage. And then we're going to look in a deeper dive on the economic drivers, not the technical, but the economic drivers for the object storage piece, the Swift piece, or Ceph, or whichever, Gluster, whatever it might be that you're using to deploy the underlying storage infrastructure for your cloud system. And then a quick wrap up at the end. So the reason why Seagate, a drive company, is here is really summarized in two nice little diagrams here. Or maybe the reason why you're here is on the left, and the reason why we're here is on the right. People are looking at the exponential growth in data that's being produced by consumers, enterprises, the Internet of Things, and they're looking at the gap between an exponential increase in the amount of data that needs to be stored and a linearly decreasing cost of storage, and maybe a marginally increasing IT budget, but an ever-increasing gap. And when we look to the right-hand side, if the market is strongly forecast now to really split between traditional enterprise storage, which continues to move up and to the right along that gray line, but the huge growth in capacity is really in scale-out systems, the type of architectures that you'd build using OpenStack infrastructure. So companies are building out huge deployments, not talking in terabytes, not talking in petabytes, not even talking about exabytes. We are talking to customers deploying zettabytes of storage, or at least significant fractions of zettabytes of storage over a relatively short time frame. There's huge growth in these deployments. And you don't build those cloud storage architectures on traditional SAN or NAS architectures that the enterprise arrays companies do. You build it on OpenStack, or you build it on other open or commercial platforms that truly scale. And that's the area that we're going to be talking about today. So why Seagate? My one slide. There are really, a lot of people say Flash, the future is Flash. Well, Flash has a huge role to play within all types of IT infrastructures. But in terms of where the majority of that storage, those exabytes, zettabytes of storage will be held, they will go onto 3.5 inch drives for at least the next 10 years, if not longer. There are really only two, arguably three companies that make 3.5 inch drives. We are one of those companies. We make over 1 million hard drives every day. We have over 50,000 people in one of the world's top 20 supply chains for building those. We are, as a core business, of which we do about, I think, 17 billion a year, one of the, a lean, mean machine for producing drives. But ultimately, and this is the bit that we want to talk more about, we are building systems and solutions for the complete infrastructure. So where you're looking at putting systems into data centers, we can help you. And the way that we help you is going forwards with a truly open approach to large-scale data management. So we are actively participating in OpenStack. We're a key contributor into some of the stuff that's going on with Swift. We are participating in the Open Compute project and have recently opened up the Kinetic standard that we have for a new drive that we have developed with a new type of interface. And we're working with partners. So we're bringing together software-defined storage, open source software, open hardware designs, creating optimized systems, working with partners to deliver different types of solution, different types of service offering for cloud providers. And I should say both public and private cloud. So this slide I usually put up just to provide a common taxonomy for describing both commercial and technical drivers for the cloud. So ultimately, cloud is about building out a pool of hardware infrastructure, compute, storage, networking, and then exposing that through a flexible set of APIs, whether that's an infrastructure as a service set of APIs or a platform as a service set of APIs. Fundamentally, it's the same set of building blocks, albeit different scales. We've then got the huge big six hyperscale providers. We have public service providers in a similar space to the hyperscale, but typically competing on a regional basis rather than on a global basis. And we'll look at some of the drivers for enabling those types of smaller service provider to compete. And then there's private cloud deployed within enterprises and typically delivered by the internal IT department. So if you're delivering a service, so let's make it clear then, there are really two business models that go with OpenStack. You're either running it internally and you are delivering that as an internal service, in which case, and we had this in one of the presentations this morning, you've got to decide whether you bill, or I think the decision was, and I would agree, you should at least bill even if you don't charge. You should be metering and monitoring the utilization of the services that you deliver within your organization. You need to provide a strong economic argument for why that is the right service on which to deploy a particular application. And then you've got public service providers, in which case you are competing with, either directly or indirectly, not only the people within your bit of the industry or your region, but against Amazon and Google as well. And so what is it, if you're delivering that service, that makes you sticky? It's how unique your service is, how available it is, and increasingly we're seeing that customers are already becoming more and more tied to a particular provider based upon whether they already have a billing relationship. It's easier for you to capture a customer and keep a customer if you've got the billing relationship with them. Obviously, that's true if they're your captive customer inside an enterprise, but very true if you're delivering public services, and the complexity of moving data. Ultimately, though, no matter how unique, appealing, or tight your billing relationship is, if you cannot deliver that competitively, then your service will fail. Whether that's an internal service, it will be displaced by something else. If it's a public service, your competition will win. So what we're going to look at is, what does competitive look like in the world of OpenStack service delivery? A key point on stickiness. If you look at the ease with which you can use heat or whatever other mechanism to spin up 10,000 VMs on your compute infrastructure, you could tear them down, you could move them somewhere else. Ultimately, the compute piece becomes pretty much weightless. It becomes truly commoditized and possible to migrate around. But although you can virtualize your storage, You cannot virtualize data. Data is an anchor that is much, much less easy to move around. To give you an example, if you have a petabyte of storage across the WAN and you've got a pretty nice 100 megabit WAN connection, it's going to take at least 2.5 years to move that data from one service provider to another. So where your data is, ultimately, is a key factor in where your compute and your cloud services are. So if you're a public cloud service provider, the message is go and capture your customers' data, capture that billing relationship, because if you've got the data, that's a huge disincentive for somebody to migrate away from you. But unless you are able to deliver that storage on a cost-competitive basis, sooner or later they'll get around to it. They'll run a parallel task, and ultimately they'll migrate away from you. If you're an internal provider, then ultimately, if you're delivering an internal private cloud, you'll end up with an organization, you'll have shadow IT moving away from you and going to an external service provider, or your project will be killed and something more cost competitive will be deployed. So ultimately, you can differentiate in many ways, but you've got to be delivering on a competitive basis. I'm going to skip those few. So let's say you're building a cloud service, and you're using Open Compute. OpenStack. OpenStack requires two different types of storage, primarily. It requires block storage, which is exposed via Cinder and attaches to your Nova compute instances. That block storage is the, it can be either persistent or ephemeral, but it's block storage in pretty much the same way as traditional SANs, where it's offered up via iSCSI or potentially Fiber Channel as well. But it's more or less traditional storage that attaches to servers. It doesn't attach to applications, it attaches to servers. Then the OS has to then provision that up through file systems and so on before it's then usable within the application space. And that's fine, and that serves its role. And clearly, with Cinder as part of OpenStack, there are Cinder drivers for a whole variety of SANs. There are Cinder drivers even for local attached storage. There are Cinder drivers for even for Swift. You can remap some of your Swift storage in as Cinder storage if you want. But fundamentally, this has to be relatively performant, because this is the storage that your virtual machines boot from and use as their local storage for their cache and for everything else that is related to the performance of your virtual machines. And that ultimately then needs to be considered on a $ per IOP and a $ per gigabyte per second basis. And those are similar metrics to the ones you'd use for any other type of traditional enterprise storage array. Object storage is different. Object storage in this OpenStack case is offered natively by the Swift service. And Swift provides a very scale-out platform for storing content. It doesn't provide block storage natively. You can do that. But natively, it provides what's called a RESTful API. It provides an API a bit like, let's make a very simple analogy, it's a bit like FTP in some ways. I know that's horrific from a computer science point of view, but from an API perspective, you're just basically putting and getting files. You can't seek into a file like you can through a POSIX API and modify a few bits and then close the file. The thing is a blob. In fact, object stores are often called blob stores because you have a piece of content which could be a virtual machine image, or it could be an MP4 file, or it could be a media clip, or it could be a zipped up archive representing the previous day's transactions. It can be anything, but basically you put it, you get it. There are relatively few transformations that you can perform on it. The big advantage of that is it's much simpler to implement in a scale-out manner than traditional block storage or file storage. But Swift, as implemented today, comes with certain economic drivers that are counter to the goal of really driving that piece of your infrastructure on a $ or cents per gigabyte per month basis. That's about dollars per IOP or cents per IOP and dollars per gigabyte per second. That's all about dollars per gigabyte per month or cents per gigabyte per month. It's not about performance, it's about storing data on a long-term basis at the right total cost of ownership. And so what I'm going to do as we go through the presentation is look at the factors that impact that total cost of ownership, the TCO, and look at, and we can talk about some of the things that are in Swift today, and some of the things that are coming with Swift, or which are already available in Ceph or in some of the other storage systems that you can plug into OpenStack, and look at what the impact will be on the TCO. I like this slide because it reminds us that there is an 800-pound gorilla in the cloud industry who is setting effectively the price that you've got to compete with. Now, I'm not saying that whether you're a private enterprise or a public enterprise, you are going to be selling directly against these guys. But ultimately, whatever you do has an incremental value relative to the economic commodity price of storage. Somewhere down the line, in pounds or dollars or euros or whatever it might be, you have got to find a way to demonstrate that your solution is better than your delta over the cost of a commoditized storage platform. Otherwise, inevitably, data will migrate away to other service providers. Amazon has done a phenomenal job in the industry in pricing and in terms of its investment, because they have over 5 times the capacity as the next 14 vendors combined, and they've spent less than its next 2 nearest competitors combined. This is what the economics of a retailer do to IT. That's why, and well, in fact, we'll look to the next slide. If you look at the success they've had with their S3 service, which is an equivalent service to the role that you use Swift for in OpenStack, that has seen exponential growth. This is now old data, this is now over a year old. They had over 2 trillion objects stored in that S3 service. And if you look at the price that is charged at, this used to have a much steeper curve. Now it's a lot flatter, actually. We've compressed the axis there. Really, the price is around about, let's call it, what should we say, 2.8 cents, US cents per gigabyte per month. That is the price that you really need. Okay, that's the cost, the price that they're selling at. You're going to have to cost and you're going to have value. You've got to try and find out how you're going to quantify that value, and that may be very easy to quantify, because in your enterprise, you'll never put data in Amazon's cloud. Great. But when your CIO comes to you and says, well, if they can do it at that price, why can't we? Internally, you're going to have to explain what it is that, from an architectural perspective, is unique about what you're doing and why you can't deploy IT infrastructure at that sort of price. OpenStack Swift has the capability to get us to these sorts of prices, but not if you take a traditional approach to building on traditional infrastructure platforms. That's the challenge, and that's why we're here. So I haven't got the full model here, but I have one. And so if afterwards you'd like to come and talk about what we think these numbers are, and we can argue about cost X, the cost of data center power, the cost of the PUE of your data center, the actual amount that you pay your administrators, and how much you really pay the distro for supporting OpenStack, or whether you just use the open source version. We can argue about that, but we've got a model that pretty much, I think anyway, you tell me if there's something missing there, covers all of the things that are associated with running a storage service. We'll plug different numbers in, you come up with different answers. Fundamentally, almost half of the TCO of your system is on the hardware, CapEx, half of it is on the OpEx, and in the OpEx side, I've included the software subscription costs, administration costs, power and cooling costs, and so on. Your goal should really be to look at how close you can get to 1 to 2 cents per gigabyte per month for running that service, because Amazon are clearly not losing money when they sell it at 2.5 cents per gigabyte per month. So they're clearly delivering it at less than that. So I would challenge you to see if you can run your storage infrastructure, your Swift service, or your equivalent object storage service at less than 1.5 to 2 cents per gigabyte per month. As I said, I'd be more than happy to go through that with you and look at where the numbers come out. One key point today, I'll cover it here, which is coming in Swift. One of the key factors that determines this is that number, the gigabyte piece here, that has to be based on the usable data. Swift copies data 3 times within the ring. So therefore, the actual cost per raw gigabyte actually has to be 0.5 cent per gigabyte per month. So just to be clear, we're talking on the actual, what I would call usable or billable capacity. And that is the target that you need to be aiming for. There was a change in the most recent release of OpenStack Swift to create storage policies. And the goal of storage policies, one of the goals of storage policies, is that behind that will come alternative storage backends to replace the current 3x replication. The goal is to put in an erasure-coded platform. And erasure coding is a means by which you can create the same level of data durability and availability, but with less overhead. So instead of copying the data 3 times, I know it's tunable, it could be 2, it could be more, but for most cases in Swift, people use the default 3 times. With erasure coding, you can change the ratio of raw to billable from 3 to 1 to, give or take, 1.5 to 1. Now, in a lot of OpenStack deployments today, at scale, people are actively looking at or deploying Ceph. So Ceph is usable both for the Cinder piece, the equivalent block storage, and for the object storage piece as well. And Ceph has only recently, but now has the erasure coding capability as well. So that's what Swift really needs to do. And Swift will help, and it will effectively reduce the amount of CapEx you need, the amount of drives, racks, servers to run Swift that you need to deliver the same amount of billable capacity. But this analysis here is based on 3x replication. And we believe we can help you get to that sort of price point. So this is one of my final slides. It's the bit where I explain a little bit more about our strategy. So Seagate used to be a drive company, has created a systems business. To create that systems business, it acquired a company called Xyratex. That's where I came from. Xyratex was a storage array manufacturer. We traditionally supplied to companies like, well, a lot of OEM customers. So there are a lot of major OEM customers. In fact, for any of you with a traditional IT enterprise data center, you will almost certainly have hardware in there that was originally manufactured and designed by Xyratex through one of our OEM customers. We continue with that business, and that's a strong business for us. But going forwards, we had created our own high-performance computing business. So we have high-performance computing arrays, which you would not use in an OpenStack environment. These are about $1 per gigabyte per second. These serve data at huge rates into supercomputer clusters. And then what I've been talking about today primarily is this one. So we're building out infrastructure solutions, the compute, storage, and networking, validated and tested with a variety of open source and commercial object storage and scale-out software stacks. So we have platforms that will deliver Swift at a competitive TCO. And then finally, the cloud services piece. We have our own business, which was previously EVault, where we run Swift in our own data centers and offer out a service called LTS2, long-term storage services. And from LTS2, or we charge 1.5 cents per gigabyte per month for LTS2. So if you want to run your own infrastructure for a private cloud or for a public cloud, second column. If you want to leverage a third-party Swift-based service at a competitive TCO, then we've got LTS2 as an offering as well. And in fact, that was my last slide. So in terms of the economic drivers, I'll just go back and recap on that. About 50 to 60% of the infrastructure that you need to run Swift is disk drives. We're Seagate, we make the disks. Another 10 to 15% are the enclosures, we do those too. The remainder of it is the power, the cooling, the data center. Well, the more efficient and dense the system is, the lower those costs are too. And finally, in terms of the administration costs, what we've been doing in some cases, and Swift in particular, is building more integrated managed solutions for Swift, which you can deploy in-house. And that means Swift, which can sometimes be a bit challenging to manage, becomes a much more straightforward to deploy solution. Fundamentally, though, Swift has 3x replication. The migration to erasure coding will have a big impact on the potential TCO you can achieve, but fundamentally will still require compute, storage, and networking in racks. And we're in the market of working with our partners to deliver that to service providers and enterprises to enable them to be competitive with some of the biggest gorillas, as I called them, within the cloud marketplace. Okay, I think I was a little early, so if there are any questions, I'd be happy to take them. Yes.
Can you repeat the question?
Yes, certainly. So the question was, can we manage a Swift solution on-premise? So I would be more than happy to have a follow-up conversation with you. We haven't publicly announced, and I won't in public forum talk to that, but there are projects that we have ongoing that we could talk to you about. Yeah, sorry for the loose answer. Yes. For anyone who's an IT vendor in this room, I should make it clear we are selling with partners. So this is not something that we take directly to end customers. Seagate's strategy, as Xyrotex's was before, is to work with partners. So our route to market, both for the services and the infrastructure, is with our partners. So we are not looking to cut people out, but we are saying that really this piece of the market requires a fundamental change in the economics, and we can help end customers, users, people deploying infrastructure, and the partners who are the traditional suppliers to those customers enable everybody to be competitive. Okay, thank you.